So here's one section from chapter 19 that relates to what we were just talking about in chapter 4, and that is balancing redox reactions. So I've done these slides so that if I don't do it right after chapter 4, we get a review. So I'll go through this really quickly. So oil rig can help us to recognize oxidation and reduction. Oxidation is loss of electrons, reduction is gain of electrons. Or we can look at oxidation states. Oxidation is an increase in oxidation state, reduction is a decrease. And so we have an example here, calcium going from 0 to +2, that's oxidation. Hydrogen going from +1 to 0 is the reduction. In redox reactions, the masses have to balance, and we're familiar with that. You have to have the same number of atoms of each element on each side of the arrow. But we also have to have the charge balancing, because electrons are being lost and gained, and so if 2 electrons are lost, then we have to have it arranged so that 2 electrons are gained. So here, when we look at the total charge on the left and the right, they're both 0. They don't always have to be 0. If you have a net ionic equation, it might be +3 on each side, but they need to be balanced. And that's not always a simple matter. And so what I'm going to teach you is the half reaction method for balancing redox reactions. So what we do is we break the equation into 2 half reactions, one for oxidation, one for reduction. We balance each of them separately and then add them back together. Here's a review of oxidation states. I don't think we need to go over that because we just learned about that. Let's go to this. Here's the procedure. This first step is good, but it's actually not absolutely necessary. Assign oxidation states to all the atoms, identify what's being oxidized and reduced. That might be necessary in a more complicated equation. For most of ours, we're not actually going to need to do that. Number 2, separate the overall reaction into 2 half reactions, one for oxidation, one for reduction. And we're going to balance each of those half reactions with respect to mass. We'll do that by balancing everything besides hydrogen and oxygen. Then we're going to balance the oxygen. These are all aqueous reactions, meaning they're occurring in a water solution. So to balance the oxygens, we can add water because water can participate as a reactant or a product. And that typically introduces hydrogen and causes unbalance with hydrogen. So then we're going to balance the hydrogen by adding H+, because these are acidic solutions, and so there is H+ present. After we do that, we balance each reaction with respect to charge. So what we're going to do there is we're going to add electrons. Electrons have negative charges. We'll add them wherever they need to be, as many as we need, so that we get equal charges on each side of the arrow for each half reaction.
The third one you said was adding water?
Yeah, well, we're balancing oxygen by adding water and hydrogen by adding H+. Next, we're going to make the number of electrons in both half reactions the same number, so that when we add them together, the electrons cancel out. And then we verify at the end. Okay, so here's about a redox reaction, and we're supposed to balance it. We're going to use the half reaction method. If we look at this, you might think, well, what's wrong with it? It's already balanced. 1 aluminum, 1 copper, 1 copper. But what's the overall charge on the reactants? +2. And what's the overall charge on the products? +3. We lost an electron somewhere. That can't happen. So it's not actually balanced. If you guys don't mind, I'm going to skip the whole oxidation state thing. We'll just start with number 2. We're going to split this into 2 half reactions. So conveniently, I have 2 reactants. So I'll just start with the first one. Here's aluminum. And aluminum is going to get changed into Al3+. I think that's obvious. Aluminum is not getting transformed into copper. So I'm going to take aluminum and the product that looks the closest to it and make that be one reaction. So I've got aluminum solid here, and I have aluminum ion there. And then I'm going to take the other reactant, and that's going to be with the other product. So Cu2 plus and Cu look very much like each other, so we can put those together, and aluminum 3 plus. Everybody okay with that? So now we're going to balance with respect to mass. Well, these are already mass balanced. There's 1 aluminum on each side and 1 copper on each side. And there wasn't any oxygen or hydrogen, so we don't have to mess around with that. So the next step is balance with respect to charge. So in this top reaction, I've got 0 charge on the left and +3 charge on the right. I'm going to add electrons that have negative charges to the right side or the left side, whichever I need, to get the charges equal on each side. So if this is +3, if I add 3 electrons over here, the 3 electrons and the +3 charges will add up to 0, which is what I have over there. Okay? What should I do to the second half reaction? I'm going to add 2 electrons to the reactant side, because these 2 electrons plus the 2 +2 charge on that ion add up to 0, which is what this charge has. Anybody have any questions about that? This is our reduction equation, our oxidation equation, because we're losing electrons. This is the reduction equation because we're gaining electrons. You should always end up with one where the electrons are on the product side and one where the electrons are on the reactant side. So each half reaction is balanced, but we need to be able to add these together, and we want these electrons to disappear. So I've got 3 electrons here, and I've got 2 electrons there. I'm going to multiply both equations so that I can get 6, because 6 is the lowest multiple of 2 and 3, right? So if I want 6 electrons here, I'm going to multiply all the coefficients by 2. So for this one, I'm going to go times 2. So that's 2 aluminums and 2 aluminum ions, and I multiply this by 2 and I get 6. The bottom, I'm going to multiply by 3. Multiply 2 electrons by 3 and I get 6. And I'm going to have 3 of those and 3 of these. It doesn't matter what the number of electrons is, we just need them to be the same. So that this reaction is giving off 6 electrons, and this reaction is picking them up. They're actually getting directly transferred from the aluminum to the copper. Now we're going to add the 2 half reactions together. So this is just like adding math equations. It helps if you line up all your reaction arrows. So we are setting this up so that I have 6 electrons and 6 electrons, and so I can just cross those off. The electrons should always cancel out. And then all I have to do is copy down the other things. So there's the aluminum and 3 copper 2 ions and 2 aluminum ions and 3 copper atoms. This equation is balanced for mass. I've got 2 aluminums, 3 coppers, 3 coppers. It's also balanced for charge now, because the total charge on the left is 3 times 2, 6, and the total charge on the right is 2 times 3, 6.
Is it always going to be start off with a net ionic like that?
No, they will not always start off with a net ionic. It could just be anything, really. Any questions? Let's do another example. Balance this one. So hydrogen ion plus chromium atom makes hydrogen gas and chromium ions. Again, I'm going to skip assigning oxidation states. Separate these into two half reactions. Okay, so there's my arrow. I'm going to put hydrogen ion here. It just makes sense to me to put the first one first. And so then, hopefully it's not too difficult to choose between these two. Which one is the hydrogen going to turn into? The H2. It's not going to turn into chromium, right? So here I've got chromium, Cr solid, and that could turn into chromium ions. I put the wrong charge there. That's not good. It's a 2+. Okay? So I'm at two half reactions. I'm going to balance them with respect to mass. So here I've just got hydrogen on each side, but I've got one hydrogen here and I've got two there. So I need to put a 2 in front of the H+ so that I can have two hydrogen atoms on each side. And then when I look at the second one, I have one chromium and one chromium. That one's already good. Next, I balance for charge. So up here, I've got 2 positive charges on the left and 0 on the right. So if I add in 2 electrons over here, 2 negatives and 2 positives add up to 0. Down here, I've got a +2 on the right. So I'm going to add my 2 electrons over there. -2 and +2 add up to 0, which is the total on that side. Now we need to make sure the number of electrons are equal. Well, on this one they already are. We've got 2 and 2, so we don't have to worry about that. So we're going to add these together. 2 and 2. Those cancel out. And just copy down what's left. Just like when you're adding, the order that you write them in the equation doesn't really matter. The charge matters. I don't know why I keep putting a 3 there. And then double check that the charges and the masses all balance out. Now that's one that you could do just balancing by inspection. It would happen to work out. Any questions? Let's do another one. Okay, this time we don't have the little notes on the side. Balance the redox reaction in acidic solution. So what do we need to do first? Split them in half. 2 half reactions. So the first thing here is Fe 2+, aqueous. Which of those products should I choose to go with this one? The Fe3+. And my other reactant is MnO4- permanganate ion. And that's going to have to be the other one, Mn2+. Now what do we do? Balance charge? Mass first. Balance the mass first. So 1 iron atom, that one's good. 1 manganese and 1 manganese, that's nice. 4 oxygens. What? We have to add water. There's nothing over here with oxygen, so we can't just change a coefficient. But these are aqueous solutions water is all over the place. So it's not like we're making something up here. So I'm going to add H2O, and here we can assume these are at room temperature, so I'm going to put L for its state. So here I have 4 oxygens. I need 4 water molecules so that I can have 4 oxygens. Okay? Now that introduced hydrogen, which wasn't a problem before, but that's okay. We're going to balance these hydrogens using hydrogen ions, H+. So I have a total of 8 hydrogens over here. So I need 8 hydrogen ions over there. Yeah, so the charge balance is going all over the place, right? That's why we keep that one for last. So we have mass balance in both of them. Now we're going to balance charges. So on the top here, I have a +2 on this side and a +3 on that side. We're not going for 0. We're going for the same on each side. So I'm just going to add 1 electron on the product side, because +3 and -1 is +2, and this is +2. On the bottom, we have to be a little more careful because there's charges in 2 different places. So here I have +8 and -1, right? So that's a total of +7 on the reactant side. And what do I have over here? I've got +2. So I need to bring this down by adding 5 electrons. And again, this math isn't hard, but the positives and negatives make it easy to screw up. So now I've got -5, and together those make +2. So we're just going to the same on each side, which means you're only adding electrons to one side of each half reaction. Okay. What's next? Yeah, we need to get the same number of electrons for both half reactions so that when we add them together, they're going to cancel out. So I've got 1 and 5. Well, I can make the 1 into a 5, right? So I'll multiply this top reaction by 5. So this will be times 5. So it'll be 5 of the irons and 5 of those irons and 5 electrons. I want to make this match with this one. Now that I've done that, I can add these together. The 5 electrons that are lost by that one are gained by this one, so they don't show up in the overall reaction. Then I'm going to copy down everything else. So I've got 8 H+, and I've got MnO4-. I'm not sure why I started with the bottom one, but I did. Doesn't matter. And then over here, Fe3+, 5 of those, and Mn2+, and ran out of room, 4 H2Os. Yes? Pardon me? No, we're not going to add hydroxide yet because this is acidic solution. So that's when we're doing basic. We'll get to that. Any questions? Always check your work at the end. Let's do another one. Here we have copper metal plus nitrate ion making copper 2 ion and nitrogen dioxide. So we're going to split these into 2 reactions, 2 half reactions. So there's copper, and then we pick the one that's most like it to be on the product side, so it'll be the 2+ copper ion. And then we're going to take the other reactant the nitrate ion, and that one's going to turn into NO2. The next step is balancing for mass. The top one's already balanced, 1 copper on each side. On the bottom here I have 1 nitrogen on each side. I have 3 oxygens on the left and only 2 oxygens on the right. To balance the oxygen, you use water. So I'm going to add 1 water molecule to the product side so that I can have 3 oxygens on each side for that bottom half reaction. That introduced hydrogen, so then I fix the hydrogens by adding H pluses. So I have 2 hydrogens here, so then over on the other side I'm going to add 2 H plus. Yes?
Why do we have to add water? Why can't we just add an oxygen molecule?
That's a good question. Why do we add water and not just an oxygen molecule? There probably would be dissolved oxygen in an aqueous solution, but there wouldn't necessarily be. We also know that it's water that's reacting and not molecular oxygen. That's about the best answer I can give you. So we have mass balance, right? Now we balance charges. What do I want to do to this top one? Yeah, I'm going to add 2 electrons to the right side. And what do I want to do in the bottom? One electron. I have 1 electron here. I have a -1 and a -1, so -2 and +2 adds up to 0, and over here it's 0. Each individual step is not a big deal, but we have to put them all together in the right sequence, and so it can be a little challenging. Now what do I do? I need the same number of electrons for both half reactions. So this one has 2, and this one only has 1. If I multiply all these coefficients by 2, then I'll have 2 electrons in the bottom, and it will still be balanced. So 2 electrons, I multiply this by 2, so I'm going to have 4 hydrogen ions. And multiply this by 2, and multiply that by 2, and multiply this by 2. Now we can add them together. The electrons cancel out. Copy down what's left. Yes?
Can I call it for NO3 before next step? I did the same. We did it, like say, NO3 and plus
I guess I'm not sure what you're asking. Part of it is because the fans are loud and you're way over there and I'm way over here. Okay, so that was in acidic solution. What if it's a basic solution? We're going to do the same thing, except when we get to the very end. Now the book shows this in step 3. We're going to neutralize the hydrogen ions. I realized yesterday while I was lecturing that it's actually easier to wait until you've got the whole thing done and then fix that part. So we can do this part at the very end, right before we verify. If you have a hydrogen ion and you add a hydroxide ion, what does that make? Water, right? So essentially we're going to neutralize all the hydrogen ions with hydroxide, and that may seem a little flip, well, we're just going to throw stuff in there. But if this is a basic solution, there are hydroxide ions in the solution, and they would neutralize any of the hydrogen ions. So let's do an example of this one. Balance the redox reaction in basic solution. So we're going to do the same process, but we'll neutralize all the H pluses at the end. So 2 half reactions, right? So I've got I minus aqueous, and that's going to the I2 aqueous. And I've got permanganate ion, and that's going to MnO2. I'm going to balance for mass. Here I have 1 iodine, and there I have 2. I'm going to put a coefficient of 2 in front of the I minus. So that one's balanced for mass. The second one, I've got 1 manganese on each side. I have 2 oxygens here and 4 over there. I'm going to balance the oxygens by adding water. So I'm going to add 2 H2O so that I have 2 oxygens plus 2 oxygens is 4, and I've got 4 over there. I balance the hydrogens by adding H+. So over here I had 4 hydrogens. So over here I'm going to add 4 hydrogen ions. This is a basic solution, but I'm going to fix it at the end. Next I balance for charge. The top one I have -2 on the left side and 0 on the right. So I need to add 2 electrons to the right side so that I have the same charge on each side of the arrow. On the bottom half reaction, we have a total of 0 on the right side. Here I've got +4 from these guys and -1. So I need 3 electrons. So I've got -3 and another one that's -4 with the +4 adds up to 0. Next I need to make the numbers of electrons equal. So here I've got 2 and there I've got 3. So I'm going to go for 6. So the top one will get multiplied by 3 and the bottom one will get multiplied by 2. So if I multiply everything by 3, I'm going to get 6 and 3 and 6. The bottom I'm multiplying by 2. Times 2 is 6, times 2 is 8, times 2 is 2, times 2 is 2, times 2 is 4. I have to say times 2 to myself because otherwise I forget what I'm doing. So I have 2 balanced half reactions and I have the same number of electrons in each of them. This is my oxidation reaction. Electrons are being lost. This is my reduction reaction. Electrons are being gained. The cool thing is you can balance these without knowing which is which. So I'm going to add these together. The electrons cancel out. I'm going to copy down everything else. So I have 6 I minus aqueous. I have 8 hydrogen ions and 2 permanganate ions. And then I've got 3 iodine molecules and 2 manganese 4 units and 4 H2O liquid. Yes?
So we're multiplying the top by 3 and the bottom by 2 because we want the electrons to cancel out.
Yes. We're multiplying the top by 3 so that we can get 6 electrons here. The bottom we're multiplying by 2 so we can get the same number, 6. It's not always going to be 6, it could be 10, it could be 8. It just needs to be the same. Because what happens here is this top half reaction loses 6 electrons. Those 6 electrons have to be gained by the bottom half reaction. If the numbers aren't equal, we are not going to get a balanced equation.
What's the most technical ones that we're gonna face?
We're not going to do anything too crazy. There are some that are real
So
bears.
is it harder than this one?
Yeah, well, you might see one harder than this one. We're not actually done with this one yet. No.
Well, we have to
So, basic solution. So what I want to do now is I want to get rid of those hydrogen ions. So I have 8 hydrogen ions. I'm going to add the same number of hydroxide ions. So I'm going to add 8 hydroxide ions. And what these are going to do is they are going to make 8 water molecules. I need this to be a balanced equation, so I have to do the same thing to both sides. So over here, I don't really have room, I'll just write it underneath, plus 8 hydroxide ions. Got to do the same thing to both sides. Well, now I've got 8 water molecules over here, and I have 4 water molecules over there. Those end up being like spectators, right? So 4 of the water molecules that were over here did not react, they're just still hanging around. So you think of this in different ways. I'm going to subtract 4 H2O, and that'll give me 4 H2Os left. Over here, I'm going to subtract 4 H2Os, and that gives me none. Now, where the heck am I going to put my answer? I'm going to put it up at the top. So now we're going to copy everything down. 6 I minus aqueous plus 4 H2O liquid plus 2 MnO4 minus aqueous gives me 3 I2 aqueous. I know those balances, right?
What's going on?
Yeah, the balances kind of self-adjust themselves, and it sounds like kind of sad electronic cows mooing. This is especially disturbing during an exam when they do that. Plus 8 hydroxides. These can get kind of long. I'm going to fix this too because that doesn't look very good. So there's my balanced equation. Any questions? I subtracted 4 waters from this side because I don't want to have water on both sides. So I'm going to, that is sort of simplifying it.
Just like if you had 2 of each all the way across, you have to
Right. Do one more example. Balance this one in basic solution. So I'm going to do this fairly quickly. So we're going to take this and we're going to split it into 2 half reactions. So we've got the hypochlorite ion, and that must be turning into the chloride ion. And then I've got my other reactant is this ion as a complex ion that we haven't learned how to deal with. That's a 1B thing, but we don't need the name of it. And that's going to turn into the chromate ion. So 2 half reactions. Balance with respect to mass. So I have chlorine and chlorine. That's all good. I have 1 oxygen here. To balance that, I'm going to add a water molecule to the other side. That balances oxygen, but now it creates a problem with hydrogens. So I have 2 hydrogens, so I'm going to add 2 hydrogen ions over here. And now I have mass balance on the first one. On the second one, I have 1 chromium and 1 chromium. That's all good. I have 4 oxygens and 4 oxygens, so that's okay. The hydrogens aren't balanced, though. I have 4 hydrogens here. So I'm going to add 4 hydrogen ions to the other side. So I got my mass balance. Yes?
So on the top you have 2H, which is a positive,
Mhm.
ClO, which is negative, so you get 0 on the left, correct?
I don't have 0 on the left. I have +2 and -1. That's +1.
But then on the right you have Cl, which is 1 negative. Is H2O a 2 positive?
No, H2O is 0.
Oh, so I see, okay. So we haven't even done the charges.
I haven't done the charges yet. I just finished the mass. So I have them both mass balanced. Now I have to balance charges. So over here I have a total of -1, and over here 2 plus and 1 minus, this is +1. All I can do is add electrons. So I'm going to have to add 2 electrons. So here I've got -2 and +2, those are canceling each other out, and then I have -1, and that's equal to -1. Here I have -1 on the left, and I have -2 and +4. If you need to write this out, go ahead and write it out. So I've got -2, and I've got +4. Okay, so that's +2, right? And on this side I have -1. So I need to add 3 electrons to the right side. So now I have charge balance. Next thing is to make the numbers of electrons equal. I have 2 in one and 3 in the other, so I'm going to multiply by 3 and 2 so that I can get 6. So I'm going to multiply the top by 3. 2 times 3 is 6. 2 times 2 is 4. 1 times 2 is 2. 1 times 2 is 2, and 1 times 2 is 2. I'm going to multiply the bottom by, see what I did there? I screwed up. Even though I was talking to myself, I still screwed up. Okay, I should have written it out. Times 3. Okay, I'm multiplying by 3. This is 6. This is 3. This is 3. And this is 3. So the bottom, I'm multiplying by 2. I better write that down because I'll forget again. So this is 2 and 2. And 2 times 4 is 8. And 2 times 3 is 6. Just so many little details. Okay, so I'm going to fix the basic part of it at the end. I can cancel out my electrons because that's how I designed it. And now I'm going to write down what is left. So I have 6 H plus, and I have 3 hypochlorite, and 2 of those chromium guys. Didn't miss anybody, did I? And 3 chlorides, and 3 waters, and 2 chromates, and 8 hydrogen ions. Yes?
Looking at the chromate on the bottom of the blue,
Mm-hmm.
what was the reason we added hydrogen instead of H2O?
Good question. Why did I add hydrogen here instead of H2O? Because the oxygens were already balanced. So 4 oxygens in this guy and 4 oxygens in that guy. So I was able to just skip past that one. Good question. Okay, so if I was doing acidic solution, this would almost be done, but I'm doing basic solution. If I was doing acidic solution, what is a little weird about this? I've got hydrogen ions over here, and I've got hydrogen ions over there. I could simplify that, right? If I subtract 6 hydrogen ions over here, then I'll have none. And if I subtract 6 hydrogens over here, hydrogen ions, I'll have 2. So I'm going to do that. I'm subtracting 6 hydrogen ions from each side. Any questions? Now I'm going to fix the hydrogen ions. So I have 2 hydrogen ions here. This is a basic solution, so I add an equal number of hydroxide ions. So I'm going to add 2 hydroxide ions to this side and to the other side. Because you've got to do the same thing to both sides. Two hydrogen ions and 2 hydroxide ions will combine to make 2 water molecules. Right? So now I have 3 water molecules and 2 water molecules. I should add those together and put them in one term. So I'm going to change this 3 to a 5. I put these water molecules along with the others up there. And there's my balanced equation. Any questions?